Good morning, my dear students, and welcome to Year 8 in Green Valley School. Today we're going to talk about the attempts of elements classification, the periodic table. Well, scientists didn't just wake up and find it there, I'm afraid. It came after years and years of hard work and research. The very first scientist who actually came up with a proper arrangement of elements was Dmitry Mendeleev, the Russian scientist. You see, one day Dmitry Mendeleev was a great fan of solitaire. He put the symbols of the elements on card pretty much like this one, with the atomic weight down below and the properties of the elements on the back. He sat there for 2 days trying to put them in any semblance of order, and then he succeeded. He gave us the very first arrangement of elements. You see, at the time we only discovered 67 elements, and he was able to put them all together in harmony in his very first arrangement. One thing you will see right here is that he arranged the elements according to atomic weight in ascending order, with elements of the same properties in the same group. He was able to connect both in beautiful harmony, and through doing that, he discovered periodicity. Periodicity is the disappearance and appearance of properties. Pretty simple, right? Well, let me make it a little bit clear. Let us say, for example, the sodium right here. The sodium reacts vigorously with water, but as you move from left to right, you'll find this property decreasing until it disappears altogether when it reaches right here and right. But then it appears again when we start in the very following period in the same group. This disappearance and reappearance of the property is called periodicity. This beautiful arrangement of elements gave us many things, but let me tell you about the most important thing that we discovered. We discovered Dmitry Mendeleev, as a matter of fact, is the one who said it. He left spaces right here. But then, why did you leave spaces, Dmitry? Dmitry Mendeleev said that one day we will discover elements that will fit right in these spaces. For example, let us say this space, the element that will be discovered will be put here. It will have properties similar to the one above it and the one below it. Same for the atomic weight. It will be between the one above it and the one below it. And actually, his prediction was proven correct when we discovered gallium, that he said, he called it ICA Silicon. Another beautiful advantage is that he corrected a little bit mistakes in the atomic weight. For example, let us say the antimony right here. He said it's not 118.25, it's 118.5. And by that, he corrected wrong estimated atomic weights. But wait, it was not all sugar and cream. There were also some problems with Mendeleev's arrangement. Let us talk about these disadvantages. But first, let me show you something. You see these two elements right here, the tellurium and the iodine? Well, the tellurium atomic weight is 127. The iodine is 126.9. So which one should go first? Of course, the iodine. But when he did that, he discovered that the iodine is in the wrong group. Its properties are similar to these elements, not these. So he had to switch the order of elements in order to put them in their proper groups. And here goes the first disadvantage. The second disadvantage, the isotopes. What will he do with the isotopes? He wasn't able to place them in his arrangement. What's an isotope? This is your task, my dear fellow class, to find out what's an isotope and why did Mendeleev have such trouble placing them in his arrangement. Thank you for watching.